So welcome back to IC Perimeter. And so last time we went over flood fill and how to essentially find the perimeter of a given blob and the area of a given blob, and we've stored it into essentially these global variables, which are our area, which will be a temporary area, a perimeter, which is temporary perimeter, and the max area and the min perimeter, which I forgot to clarify last time. So this is going to be the minimum perimeter of a given region with the maximum area because of the condition that we're given here, that if multiple blobs are tied for the largest area, we have to print the one with the minimum perimeters. That's why we need to store minimum perimeter. So I went ahead and wrote our file output things. So we need to output our max area and our minimum perimeter, as we know, with the space in between, which we should be wary of. So now we'll go ahead and think about a given square, a given I and j square. So if that square, if grid ij equals 1, if that's equal to 1, and so if it has a hashtag, and if we haven't visited it already, we need to make sure that's the case. False. Equals false, my bad. Then we need to flood. So then we need to set our area variable as 0, initialize these, perimeter equals 0, set those, and then now we can do our flood fill. We can start filling everywhere from I and j. And note that since we have checked, we won't be filling the same region twice. We will only fill a given region once. So ij grid. So we've filled that, and now we got to do some kind of comparisons with area and perimeter, but that's fairly simple, right? If this area, so we should probably initialize minimum perimeter and max area somewhere. So let's just do that here, I guess. Set max area to be a really small number, 0, and max perimeter, set it to be a very min perimeter, my bad. Min perimeter, set it to be a very big number. All right, cool. So if this temporary area is bigger than our max area, the temporary area that we're setting is bigger than our max area, then we can set the max area to that area variable, and we need to set the perimeter, because this is the maximum region, so it has a given perimeter. So we need to set the minimum perimeter to whatever the perimeter of that region is. Okay, and the good thing about this is when we go the next time through the loop, area and perimeter will be set to 0, which is good. Perimeter. Okay. So, and we need to check whether, of course, if two regions are tied. If the regions are tied, we can do this. Well, if the areas are equal, then we don't need to do anything with the area, but if the perimeter is less than our current minimal perimeter, then we need to set our minimum perimeter equal to the temporary perimeter of that region. So yes, and that actually concludes the problem. So there's really nothing else we have to do. So let's just test it for the perimeter.in here. So let's just run the code and see what happens. Run as Java application, perimeter.java. Perfect. And it should have recorded in perimeter.out, which is right here. Perimeter.out 1322. Is that what it's supposed to be? Yes, that's what it's supposed to be. So now we can take our entire Java file. Let me get that ready. So perimeter properties. this is the file. And now we are ready to go to the USACO server and enter this. This is the code that I submitted during the contest. Let me move this on here. Go back. So now let's submit. Shoot. I copied this wrong, so I'm going to go perimeter. Let me extend the display a little bit so you can see. And let's submit the solution. See what happens. Okay, pass the first two, first 5. Good. The 11th case. Yes, and it got it. It barely got that case. So this case, yeah, I'm surprised it got that. It got 3, 6, 8, 1, but we got all the cases, so we are done.